So, funny story. This is what was supposed to be printed on your quiz sheet. 7 to the 12th times 7 to the 4th times 7 to the negative 16th power, in which case you would have gotten 7 to the 0 power, which of course is equal to 1, and that's why this was in this section of negative and 0 exponents. But for some strange reason, the printer didn't copy this very well. In fact, you couldn't see this at all. Nobody could. So that's why you wound up with a problem that really didn't look like it went in this section. It was just a straight up adding the exponent problem. 12 and 4 make 16, and instead of a negative 16 to bring it out of 0, we have a positive 16, which makes our base stay the same, and our exponent would actually have been 32. So next time I'm going to make sure that the copier gets everything that it's supposed to. All right, for B, we've got several unhappy campers here, right? This dude wants to go downstairs. This dude wants to come upstairs. So let's go ahead and make everybody happy and then figure out what's going on. So the k to the negative 8th is going to come down here to the bottom, and now he's positive. The k to the negative 4th is going to come up to the top, and now he's positive. And now we can simplify this because this is division. What do we do when we're dividing? We subtract the exponents. So 8 subtract 4 is 4. So we're going to get k to the 4th power. And the question now is where? Where is it going to be? It always goes wherever the bigger exponent is. So since that's down here, we're going to wind up with k to the 4th power on the bottom, and we need a placeholder on the top. The other option that some of you, I think, figured out is, since it's division, we could just go ahead and subtract. So we would have negative 8 minus negative 4, leave, change, opposite. We would get negative 4 as our exponent with a k as our base, and he's not happy, so he wants to go down to the bottom, and this is what we would wind up with. I don't think either one is necessarily easier or harder than the other. It's just a different approach. But I personally, I don't like to deal with negatives if I don't have to, so I try to get rid of them when I can. For C, we deal with our coefficients first because those are just regular old numbers. So that's a fraction that can be simplified by dividing by 6. So 6 divided by 6 is 1, and 18 divided by 6 is 3, so we wind up with 1/3. And now look here, guys. The easiest thing to do here is just say, oh, these cancel out. They're the exact same thing, right? If you have the exact same thing, base and exponent on the top as you do on the bottom, gone. You could have moved the h to the 12th at the top, moved this one to the bottom, you wind up with h to the 12th on the top divided by h to the 12th on the bottom. You could have subtracted those exponents and gotten a 0 exponent, which makes h to the 0 power, of course, equal 1. But we don't really need to write 1 because 1/3 times 1 is 1/3, right? So this is really all you wound up with, was just 1/3. That was your answer. And the last one, probably the most difficult, rainbow rule, right? So 5 gets raised to the negative 2nd power. When I multiply these exponents, I actually get a to the positive 8th, and I get x to the positive 12th. So both of our variables are happy where they are. So a to the 8th is going to be on the top, and x to the 12th is going to be on the top, excuse me. The 5 is the only guy who's not happy. So he wants to come down to the bottom. And when we do that, we could probably just do this in our head. 5 to the 2nd power is 25. So he's going to wind up down here. So that is your final answer for that last problem.